Hi, my name is Andy Boyle, and welcome to The Primer. This is a video how-to series on the Forensic Technology product line and some tips and tricks on how I think you can best use them to get the most efficient use out of them.
In the previous episode, we saw that quantitative analysis was run automatically when it compared testfire 2 to testfire 1. For this episode, let's go more in depth in the quantitative analysis, and I'll show you how it can be run on an entire workspace. So first we're going to click on the QA button up top here. And now in this window that just opened up, we have a summary of all the acquisitions in that workspace that have conventional rifling. If there were additional items in this workspace, here we can see it's all 5 tiles here, represent the 5 options down here. If there was a 6th and 7th that were polygonal, they would still be visible to work with here, but they would not be applicable to the quantitative analysis, which is only for conventional rifling at this time. So let's take a look at testfire 1 and 2. This is from a known source, so we are going to put that as a known group 1. That's because the gun was in the lab, we test fired that, we know that those came from that firearm. And if there was a second firearm there, we could put those test fires as known 2, known 3, etc. Up top here now, we have acquisitions unknown 1, 2, and 3 that are remaining. We don't know their relationship, so they go in the unknowns pile. And so when I run the quantitative analysis here, what's going to happen is unknown 1, 2, and 3 are going to compare against each other. They're also going to compare against testfire 1, testfire 2, and separate from that, testfire 1 and testfire 2 are going to compare against themselves as well. And so we're going to learn the relationship of everybody within that workspace. Let's go ahead and do that. And here we have the results of the quantitative analysis. I'm going to go ahead and slide this down so that our graphs get a bit bigger here, fit to screen. And so on the left side, you've got the best Lee rebel graph, and on the right side, you've got the best phase rebel graph. So what happens is all of those individual exhibits were compared to each other in every possible alignment, and then they are displayed here based solely on the best performance of the Lee on one compared to the Lee on the other, only the land engraved area of each one of those, while here it's actually the cumulative score of phased Lees compared to each other. So this is just a single Lee to Lee score between all of these items, and this is a phased overall agreement score between those same items. If we look over here on the far right, we have a series of drop lists here. Everything with a blue marker in the graph, everything with a blue marker are the unknown items that were compared to the 2 knowns, testfire 1 and testfire 2. So the unknowns compared to the test fires all ranked with the blue markers here. Let's go ahead and turn those off for a second and drop down to the red triangle here. That's the unknowns compared only against the other unknowns. And so you have the red triangles here showcasing that performance. Let's get rid of that for a second as well. And that only leaves the green square here, which is the known compared to the other known. And this is the same positionment that it had in the previous episode where we saw the yellow star where it was 12.04. That's still the same score here. Even though it was run in the QA larger mode, it still came out with the same result here for its overall performance. But that's what we're seeing here now is that testfire 1 to testfire 2, for the best Lee, you've got best Lee pattern matching score, best Lee line counting score, best Lee false match rate. These score results here are all to this graph. And then best phase pattern matching score, best phase line counting score, best phase FMR are for this graph here. We also have what's called the subclass warning coefficient, and that is applied when the result has it ranked higher than this separation line here, which is the equivalent value of 4. If it's above that separation line and below this subclass warning line here, in this zone here, it will give you a warning about subclass to the point where so long as the score itself within this subclass warning coefficient is below 0.8, if it's below 0.8, it's not likely subclass. If it's 0.8 or higher, then it most likely is subclass. And the agreement you see is visible, but it's most likely because of subclass if you're 0.8 or higher. And let's pause there for this episode, because actually let me turn these both back on here. We'll get the full list, and then we'll end this episode here, because the next thing I want to talk about is the clustering, and that's going to take an episode on its own. So I hope you tune in again next time around.
Thanks for watching. Stay tuned to the channel for future content, and I hope to see you soon. Bye-bye.